All right, so we'll talk a little bit about translational devices and startups, and specifically venture-funded startups, which is where I've spent a lot of my time. Just a little bit about my background. So I've been working on medical devices since '91, and before that actually a bunch of years doing RF and microwave and optics and things like that. I've been involved in 4 kind of big startup cycles and consulted for a bunch more. I've helped, I've participated in 2 IPOs. I've helped raise a lot of venture money. So I spent an awful lot of time with PowerPoint in front of investors. And also participated in a lot of first-in-human studies. So seen the whole cycle a bunch of times now. And just some show and tell pictures here. These are automatic external defibrillators. That was a company called HeartStream. One of Natish's former students was our clinical guy there, Brad Glenner. This is the one you can buy on Amazon, by the way. It's actually got an over-the-counter approval, which is an unusual thing. This is the North Star Neuroscience System. That was research for stroke treatment, and then some images below are from my time at NeuroVista, where we did research on a seizure prediction system that we studied in the clinic in Australia, actually. So there's good, bads, and uglies. So a couple good things about VC-funded startups. So it takes a lot of money to do this kind of work, as you probably are all figuring out. And if we look around, for example, in the field I've been working in a lot, which is epilepsy, we could go look at NeuroPace, and I think if you try to tally up the amount of money that's been raised there, it's somewhere in the order of $300 million over a lot of years. So these can become very large, expensive programs, and you have to find investors that can participate at that level, and venture capital can do that. They're also well adapted for high risk, high reward kind of opportunities. That's really what venture is designed to take advantage of and pursue. So they tend to emphasize large unmet needs, which can be exciting for us technical people that like to work on something that's important and relevant. Startups, you have a sense of mission. Tim has got a lot of meetings today. You've got the ability to bring in really top-notch people, and that's one of the real joys is, you've got the resources and this mission and these concepts, and you get to work with super smart people, and that makes it exciting. And because there's some equity on the table, ideally, you're all in the same boat. Investors want to see the equity become valuable. You as an entrepreneur want to see the equity become valuable, so there's some alignment. But there's the other side of this too, and if you're thinking about these kind of efforts in startups, you really need to be aware of these things. So first off, we're always competing for investors' dollars, and in today's economy, there's a lot of other things besides medical devices to invest in. So if you're going to propose a 20-year program that has a lot of risk in it for a medical device, you're competing against a guy that says he can make a lot of money with a phone app that can be done in 6 months for not much money. So that's affecting how we, it affects your selection of ideas and who you want to work with as far as the investors go. You have to realize, and this is, I think, an important thing to try to internalize, but you have to realize that your interests are not fully aligned with investors. So you as the entrepreneur, you're looking, this may be something you came up with as part of your dissertation or something you've been working on, and you're excited about it, and you want to see it go someplace, and you want to help people with it. So there's this chance to make a difference and engage in something that's professionally fulfilling. From a financial side, you're going to put a lot of time you're going to put potentially a lot of your career into this. And so as an investor, you would like it to pay off. You don't want it to be too risky. You want it to be the right amount of risky. Venture investors are building a portfolio out of a whole bunch of risky investments. So each investment is pretty darn risky. On average, they want to make money. But for your particular investment, they're probably actually willing to tolerate more risk than you can be excited about as an individual who gets to place one bet. You're placing the one bet on your company. They're placing bets on dozens of companies. So they actually may push you into a little riskier area than you might be comfortable with. They're also, you know, we all have masters, and they need to make money for their investors. And by the way, you know, if you have a retirement program at a university or something, you may be one of their investors. So it makes sense that they want to make money for their investors. There's an important party we've left out of the list so far, and that's study subjects, and I'm going to touch on them at the end. So I don't think it's possible for me to compress 20-something years of this kind of work in a couple slides. So I'm only going to hit a couple of high points on how to think about making the most of the good and avoiding the bads and uglies. You've heard this already a couple times, and now you hear it again, to expect the unexpected. When you're doing early work, things usually don't run per plan. Tim's wrap-up he was advising you to think balance the optimism and the realism, and I'll maybe say it slightly different and say that, you know, try to be really, really objective about program risks, schedule and budget, and beware the Kool-Aid. And what I mean by this is when you go to raise money for an opportunity, you're going to be putting a pitch deck together and telling people about why your idea is important and how many people it can help and why you've retired lots of technical risk and how you're going to make progress. And you're going to, you know, you'll work at it until it's a really good sounding story. And you have to not completely believe it. You are selling. And so somehow you have to like get this practice of saying, okay, it's okay to sell, but I'm also going to be very objective about my plans and make sure that I understand my risks and I'm not sweeping stuff under the rug. So you want to be prepared for the unexpected. You want to have things not, you don't want the thing to fall apart if things don't go as planned. So a couple of pointers. Have an engineering presence in the clinic. So a lot of places will use a contract research organization or send people that are really kind of more compliance minded out in the clinic, and they're going to make sure that the paperwork is filled out correctly. I'd really like to see engineers and technical people go out in the clinic, and there's a lot you can pick up that might not be on a case report form, but could be, hugely impactful to the program. Build flexibility and softness into your systems. You've heard and seen some examples of that already. Be prepared to, a lot of venture investors want to see companies move straight into the clinic, and they don't want to see them investing in preclinical work. And so it's too researchy. The money's in the clinic. Let's go straight to the clinic. But if you run into an issue, you'll sure be glad that you've got your connections in your relationships with preclinical folks who can help you understand the problem you just ran into. Collect every bit of data you can. Let me explain these slides. This is data that came out of the NeuroVista system. This was a system for seizure prediction. So it's an implantable system, 16 EEG channels on the brain, data collection transmission unit, then an external device that processed the data and ran an algorithm to detect increased seizure risk. This is a plot showing how subjects were doing when they recharged the device. So they had an inductive charging link to charge the battery. We were really worried that patients would have troubles managing the system. It's a lot, to send someone home with an implant and an external charger and all these things, and they have to manage it on a daily basis. It's asking a lot. So we instrumented it. So each of these bars here is a day, midnight to midnight. The blue area is when this particular subject was charging the device. And by the way, the little lightning bolts are when we had seen seizure activity in the EEG. And what we found, very pleasantly, was that these patients managed the system just fine. As it turns out, epilepsy, patients who have epilepsy, subjects who have epilepsy, tend to be very habit-oriented because it helps them manage the disease. And so they actually ended up being superstars in terms of compliance and managing the device system, which was a nice surprise. This is interesting, by the way. This guy is having a seizure right in the middle of charging, so he may have just been not aware during that time, but he still managed to keep the charging going. This is a similar kind of graph showing a different thing. So we were also able to measure our telemetry performance. There's a 2.4 gigahertz telemetry link from the implant to the external device. This is earlier in the study and later in the study. Problem, so whenever the purple is showing up, we're not getting a connection. So we had done lots and lots of testing ahead of the study, thought we had a very robust link, and we were wrong. It wasn't as robust as we needed it to be. So we needed to make some changes on the fly, and because we had a very soft system, we were able to make some protocol changes. We were able to, we actually added another antenna and went to an extra receiver on the handheld and got this kind of improvement. So expect the unexpected. Make sure that your devices have a lot of built-in instrumentation to collect this kind of data. Be prepared to respond and improve. Managing program inertia. So this is a pretty abstract concept, but as you spend more investors' money and go farther down the road, it gets harder to change course. As much as we'd all understand the validity of sunk cost kind of concepts, it doesn't seem to work exactly in the boardroom. People start getting tied to certain directions and they're unwilling to change them. So beware program inertia. Things that will add to inertia: head count, investment in the facility. Andrew mentioned ASICs and things, so premature investments in making it a commercial-like product versus maybe a research-like product. Good things are getting out to the clinic as soon as you can and learning. All the learning takes place in the clinic. Leverage what you can. Leverage existing devices from other people. Try to piggyback on existing clinical studies. That's a good way to get in the clinic. And I'll maybe just speak to this last point and provide an example. So at NorthStar, to get in the clinic early, we talked to, Steve's going to have to remind me of the new name. LivaNova. I have a learning disability here. I'm going to try to not say the old name. So LivaNova. So they very helpfully provided IPGs for our early studies, which was awesome. So we got in the clinic a lot sooner and started gathering data, and that was super helpful. Now here's the backside of it. So we had done a lot of preclinical work, and we figured out what kind of parameters worked best. This is for a stroke, for a system to help improve recovery following stroke. This is a pulse generator, cortical electrodes, and combined with rehab. Anyways, we had a lot of data on what would work well in the clinic based on our preclinical work. We couldn't implement quite what we wanted with the LivaNova device because it was designed for a different application. Once we did get that data, however, no one wanted to change away from those parameters and go to other parameters. We had built inertia. We had some early results. People were going, do we go to where we think it's going to work better based on a lot of rat data? Or do we stick with the results we got in our early human work, which was pretty good results, and that ended up being probably not the best decision. They missed endpoints in the pivotal study, and that was at least a contributing factor. So beware inertia and beware the decisions it can drive once the program's been running for a while. Regulations and standards. So this is, I think everybody understands, well, a lot of people understand this is important and impactful, but it's something that you really are going to have to commit to learning about and understanding in order to be effective and get a translational program underway in a startup context. This is just a snapshot of a directory full of all the standards I keep on my laptop, and that's not showing all of them. It's a lot. Why do we have all this? Why is it regulated? It's regulated because as a group, us humans have not done a very good job of treating each other. And if we go through history, and I recommend taking a look at things like the Belmont Report, which kind of talk about this at a very high level. we've done a lot of very not nice things to each other in the, nominally in the name of research, and that's regrettable. And that's why we have these regulations. The rules get made when somebody does something bad and we decide we don't want to do it anymore. And unfortunately, a lot of bad things happen, so we have a lot of rules. And that's how it is. So get to know these things. I threw a few up here, but if you are in this business for a while, you'll know what's behind each of these regulations and these reference standards. There's a couple different approaches you can take, and I've seen all of these out there. But if maybe you guys are familiar with Carnegie Mellon's capability maturity model for software organizations. We're kind of at the bottom end, you're hacking, and at the top end, you're a very capable organization. And I think the same thing applies to these systems and knowledge of these regulations. And so I kind of made up my own maturity model, but at the bottom, you've got people that are kind of only vaguely aware that this is a regulated industry and that rules exist. There's a level here, and you actually see this a lot with kind of type A CEO, go people. It's, I'm going to do it my way, damn it, and, out the window with the rules, stuff the rules. And then you'll see people that capitulate, say, great, okay, just tell me what I got to do, I'll do it, I'll comply, and that's about as far as they make it. But the one you want to gun for, and good luck, it's hard to get there, but it's really enlightenment. All these rules, all these reference standards contain an enormous amount of helpful information. And you really should treat it as research. You should get to know it, you should mine it, you should understand it, because it's going to help you out. It's not easy. I think most organizations are probably kind of in here, I would say, based on my informal polling. But if you can work yourself down to this end of the maturity model, you'll be doing yourself a great favor. And remember that if you miss something, that's the kind of thing that can lead to a very late stage redesign, significant, refactoring your software. And, if you're really out of line, you can get crosswise with regulators who are there to protect the public. And that's not where you want to be. So last slide. I mentioned study subjects as a stakeholder in all this, and I want to suggest to you that it's important to keep these study subjects in mind. Try to walk a mile in their shoes. So a lot of these people are facing a life-changing disease or injury. If you're doing early clinical work, you're saying, okay, please read my informed consent. I have very little data saying that this works. There may be very significant risk, but I want you to participate in this study anyways. That's a pretty big ask. What is amazing to me, and amazing in a really good way, is how kind of courageous these early study subjects are. And if you've had a week where you've had to sit through a bad political news cycle or something, and the whole world seems to be spinning off its axis, and it's very negative out there. I tell you, it's very re-energizing and centering to hear from people that choose to participate in these early subjects. A very typical thing you'll hear is that, okay, I know this is risky, I know it's early, but I'm looking for some help, and I understand it might not work, but if it helps the next guy, that would be awesome. I'll do this, and that can be a huge part of their motivation. So these are amazing people, and while you're on this highway, on this fast lane, trying to get a product out, there's going to be a lot of things competing for your interests, and distracting things, and pressure, and investors pushing you to do things faster, and lots of regulations to learn, all these things. It can be kind of bewildering, but I want to suggest that you really want to keep your eye on the well-being of the study subjects. If you make that your North Star, and you're gunning for that at all times, that's going to help you get your priorities straight and keep the program on track. Thanks.